Hello everyone. In this video, we are going to solve problems from the chapter Errors and Measurements. And the questions are mainly from previous year's NEET exams. So let's solve our first problem, which is a metal wire has mass 0.4 plus minus 0.002 gram, radius 0.3 plus minus 0.001 millimeter, and length 5 plus minus 0.02 centimeter. The maximum possible percentage error in the measurement of density will nearly be, and 4 options are given. So the given quantities are mass, which is 0.4 plus minus 0.002 gram, and which can be written as m plus delta m. Here delta m is the error in measurement of mass. Similarly, for radius, it can also be written as r plus delta r, and for length, it is l plus delta l. Now we know that density is given by rho equals to m over v. Now according to the question, the mass, radius and length are measured for a metal wire. Therefore, for the metal wire, the volume is given by v equals to pi r square l. Therefore, density rho will be m over pi r square l. Now, if we take logarithm on both sides, then it will be log rho equals to log of m minus log of pi minus 2 log r minus log l. Now take derivative on both sides of the equation, then it will be delta rho by rho equals to delta m by m minus 0, as pi is constant, so its derivative is 0, minus 2 delta r by r minus delta l by l. Therefore, maximum percentage error in measuring the density of the wire is equals to mod of delta m by m times 100 plus 2 times mod of delta r by r times 100 plus mod of delta l by l times 100. Now, from the given data, we can put the value of delta m, delta r, and delta l and l. Okay, so if we put all the values, say for delta m it is 0.002 and m is 0.4 times 100, plus for r it is 0.001 and r is 0.3, and for delta l is 0.02 and l is 5. So if we calculate this, the maximum percentage error in measurement of density will be 1.6%. Therefore, option B is the correct answer. Now let's go to our next problem. Next problem is the area of a rectangular field in meter square of length 55.3 meter and breadth 25 meter after rounding off the value for 2 correct significant digits is, and 4 options are given. Now to solve this problem, we are going to use the formula for area for a rectangular field, and area is given by length times breadth. So here length is 55.3 and breadth is 25 meter. Therefore, area is 1382.5 meter square. Now we have to round up this value up to 2 significant figures, and the answer will be 14 times 10 to the power 2 meter square. Therefore, the correct answer is option A. Next problem is the percentage of error in the measurement of G is, and it is given that G is equals to 4 pi square L by T square, L is equals to 10 plus minus 0.1 centimeter, and T is equals to 100 plus minus 1 centimeter, and 4 options are given. Now to solve this problem, let us start with the given expression G is equals to 4 pi square L over T square. Now taking logarithm on both sides, we can write log of G equals to log of 4 pi square L over T square, which is equals to log of 4 pi square plus log of L minus log of T square. Here we use the formula of log of ABC, which is equals to log of A plus log of B plus log of C. And also we use the formula for log of 1 over C, which is minus log C. Now here 4 pi square is a constant and doesn't contain any error, so we can safely neglect this term. And for rest of the terms, we can write log of E equals to log of L minus 2 times log of T. Here we use that log of A square is equals to 2 times log of A. Now differentiating both sides of the equation, we can write dg over g equals to dl over L minus 2 times dt over T. And writing this expression in terms of maximal permissible fractional error, we can write delta g over g equals to delta L over L minus 2 times delta T over T. Therefore, percentage error will be delta g over g times 100 equals to delta L over L times 100 minus 2 times delta T over T times 100. This is the percentage error. But we are interested in maximum percentage error. So each error should be added up and the final expression will be mod of delta g over g times 100 equals to delta L over L times 100 plus 2 times delta T over T times 100. Now the errors in measurement of L and T are given, which is delta L over L equals to 0.1 over 10 and delta T over T is 1 over 100. Therefore, if we put these values in the above expression, then delta G over G times 100 will be 0.1 by 10 times 100 plus 2 times 1 over 100 times 100, which is equals to 3%. Therefore, the correct answer is option D. Now let's go to our next problem. Our next problem is a screw gauge gives the following readings when used to measure the diameter of a wire. Main scale reading is equals to 0.0 mm. Circular scale reading is 52 divisions. Given that 1 mm on the main scale corresponds to 100 divisions on the circular scale. The diameter of the wire from the above data is, and 4 options are given. Now to solve this problem, we are going to use the formula for the diameter of a wire, which is D is equals to main scale reading plus circular scale reading times least count. Now here least count is 1 over 100. So we can write 0 plus 52 times 1 over 100, which is equals to 0.52 millimeter, or it is equals to 0.052 centimeter. Therefore, the correct answer is option D. Our next problem is a screw gauge has least count of 0.01 millimeter and there are 50 divisions in its circular scale. The pitch of the screw gauge is, and 4 options are given. So according to the question, it is given that least count of the screw gauge is 0.01 millimeter and number of divisions on circular scale is 50. Therefore, pitch of the screw gauge will be equals to least count times number of divisions on circular scale, which is equals to 0.01 times 50 equals to 0.5 millimeter. Therefore, option B is the correct answer. So that's it for now. See you in the next video.